So let's look at this equation. T square z double prime plus 29t z prime plus 196z is equal to 0. So let's write it out like that. So we know that the auxiliary equation is AR square plus B minus A R plus C. So here A is 1. So A is the coefficient with this term, the double degree term, and B is the coefficient of the single degree term. So B is 29 and C is 196. So auxiliary would be R square plus B minus A times R. So B minus A is 29 minus 1, which is 28. And now this one is the complete square of R plus 14. So R is negative 14. Now, if you don't spot that this is a complete square of R plus 14, you can use the quadratic formula and you will only get negative 14. So that means it's a repeated root. And therefore, it's that second case. So the general solution is y is equal to, so let's just recall what it was in case of repeated roots. In case of repeated two real, we have a repeated root. It was y is equal to c1t to the r plus c2t to the r ln t. So c1t to the r, c2t to the r ln t. C1t to the r is negative 14 plus c2t to the r, c2t to the negative 14 times ln t. So we can write it as a t power negative 14 plus b t power negative 14 ln t. Okay, now this one at first sight doesn't look like a Cauchy-Euler equation because remember we need to have the form. We just go back. We said that this is the Cauchy-Euler form, a t square y double prime. So with the y double prime, you have to have t square. With the y prime, you have to have t. And y, you don't have anything, just a constant. So at first sight, this equation that we just saw doesn't look like a Cauchy-Euler equation because you have t's in the denominators. But if you multiply both sides by t square, so let's see, let's just first copy this. So it'll be w double prime plus 14 over t w prime W double prime plus 14 over T W prime plus 42 over T squared W. And multiply both sides by T squared. So now it becomes T squared W double prime plus, and when you multiply this term by T squared, we'll have T squared divided by T is just T on the top, so 14T. And when you multiply this term by T squared, this T squared will cancel out and you'll just have 42W. And so here, A is equal to 1, B is 14, C is 42, and then you proceed as before. So auxiliary would be R square, AR square is just 1R square. B minus A is 13 times R plus C. And this one would factor in will become like the first case. So that's now just like the first problem. So I will not finish it. And now let's look at the next one. So this is nothing different. The only thing is you will get complex roots, and then you just look at the third case that we talked about. Here it's again the same. You multiply by T square on both sides first, and then that becomes a Cauchy-Euler equation. This one is already fine. Here it's an initial value problem. So let's do this one. So T square y double prime minus 9T y prime plus 24T. And then y1 is 2, y prime 1 is 4. T square y double prime plus 9T y prime plus 24y is equal to 0. y1 is equal to 2. Y prime 1 is equal to 4. So I think this was negative 9T y prime. Okay. So here the auxiliary equation auxiliary equation, let's just first note A, B, and C. A is equal to 1. B is equal to -9. C is 24. So auxiliary be AR square, so be 1R square plus B minus A is -9 minus 1 R plus C. So that is R square minus 10R plus 24, R minus 6, R minus 4. So R is 6 and 4. And we have Y is equal to, so in this case we know it's real and distinct roots. So here it's C1t power R1. So C1t power 6 plus C2t power 4. But now we have initial conditions, so we can find the C1 and the C2. So Y1 is 2. So that means 2 goes for Y and 1 goes for T. So 1 power 6 is 1 and 1 power 4 is 1. So that's one of the equations we get. And then the second equation involved the derivative y prime 1. So we have to take the derivative. So y prime is equal to, so when you take the derivative of this, it's 6c1t to the 5 plus 4c2 t cube, and we have y prime 1 is equal to 4, so 4 goes for the y prime and 1 goes for the t, so 6c1 plus 4c2. And this can be simplified. You don't have to. One way to do it is to multiply the first equation with -4, because then this would be -4c2, and when you add it with this, the c2 will go away. So I can multiply the first equation with -4. It's -8, -4c1, and -4 times c2 is -4c2. And now you add them up. So 4 minus 8 is -4. 6 minus 4 is 2c1. This c2 part is gone. So this one gives us c1 equals -2. C1 equals -2. You can substitute it in the first one. 2 is equal to C1 plus C2. 2 is equal to C1 is -2 and plus 2 plus C2. So 2 is equal to C1 plus C2, and from here we get C2 is equal to 4. So we have the C1 and C2. C1 is -2, C2 is 4. And we have this as the solution. C1t to the 6 plus C2t to the 4. C1t to the 6. And C1 was -2. And C2 was 4. So plus 4. And then it was t power 4.